Welcome to further mathematics class. In this class, I'll be taking you through vectors. The lesson outline include scalars and vectors, addition of vectors, subtraction of vectors, and multiplication of vectors by scalar. Scalars and vectors. A quantity that has magnitude but no particular direction is described as scalar. A quantity that has magnitude and acts in a particular direction is described as vector. Here is a diagram that describes vectors. We have the vertical and the horizontal axis. Vertical axis is y and the horizontal axis is x. A vector must have a magnitude and a direction. Three vectors here start from the origin. One starts from the origin and is between north and east. Another one is between north and west, while the third one is between south and east. A vector can start from any part of the graph. That is, it's not in all cases that all vectors must start from the origin. The most important thing to consider when drawing a vector is that it must have a specific direction. The two words that describe a vector is direction and magnitude. Magnitude is also known as the length. The components of a vector can be represented in row or in column. Vector V is represented in row, which is 3, 1 as its component vector, and in column 3 and 1. This graph explains the vector V. Vector V has the component 3 and 1, which means that x is equal to 3 and y is equal to 1. 3 is along the horizontal component and 1 is along the vertical component, where they both form a vector u. Vector u has a component -2 and 3 in row or in column. Vector u starts from origin and it is drawn in the negative side of x and is between north and west. Example: determine the length or the magnitude of the vector v, where the components are 3 and 1. That is, the x component is 3 and the y component is 1, which means that 3 is drawn in x direction and 1 is drawn in y direction, which gives that vector v. To determine the magnitude of the vector v, the x component is 3 and the y component is 1. The magnitude of the vector v is the hypotenuse from that triangle, where the opposite and adjacent is 3 and 1 respectively. Now, by using Pythagoras theorem, the magnitude of v is equal to the square root of 3 squared plus 1 squared, which gives square root of 10. Addition of vectors. Example: given the vector v with x component 3 and y component 2, and also vector u with x component 1 and y component 4. Vector v plus vector u is equal to 3 and 2 component plus 1 and 4 component, which is equal to 3 plus 1 and 2 plus 4, which gives us 3 plus 1 is equal to 4 and 2 plus 4 is equal to 6. Therefore, the addition of vector v and vector u is 4 and 6, where the x component is 4 and the y component is 6. To draw the diagram for this vector v has the component 3 and 2 and vector u has the component 1 and 4, where the addition of both vectors is 4 and 6. The vector v starts from the origin and also vector u starts from the origin, with both vectors between north and east in different direction. Vector v is drawn by locating the points 3 and 2 on the graph, and also vector u is drawn by locating the point 1 and 4 on the graph. Both vectors are drawn with these 2 points and are facing different direction. The resultant of these 2 vectors is vector u plus vector v. Subtraction of vectors. Before we proceed to the subtraction of vectors, we need to understand the concept of a negative vector. If vector A is going in a forward direction, then negative vector A is going in a reverse direction. And if vector A is going in a reverse direction, that is backward direction, then negative vector A is going in a forward direction. This is a concept. Now, vector subtraction. Vector u has a component 3 and 3, and vector v has a component 4 and 1. Vector u minus vector v is equal to vector u plus negative v. Therefore, vector u in column, which has a component 3 and 3, plus negative vector v is now minus 4 and minus 1. Now, to solve further, we need to understand that plus multiplied by minus is minus. Therefore, 3 plus minus 4 is equal to minus 1, and 3 plus minus 1 is equal to 2. Therefore, vector u minus vector v is equal to minus 1 and 2. That is, minus 1 is represented on the graph as the x component, and 2 is represented on the graph as a y component. To represent these vectors on the graph, we'll locate the point 3 on the x-axis and point 3 on the y-axis and draw vector u. We locate the point 4 on the x-axis and 1 on the y-axis and draw the vector v. Vector u and negative v is in northwest direction, and that gives the resultant of vector v and negative vector u, which makes the third side of the vector diagram. Multiplication of vectors by scalar. Recall that a scalar quantity has only magnitude, and the magnitude here is 2. While vector has both magnitude and direction, which is v. V has a component vector 1 and 2. Therefore, the multiplication of the scalar by the vector is 2 times v, and that gives 2 multiplied by the component vector 1 and 2. 2 multiplied by 1 is 2, and 2 multiplied by 2 is equal to 4. Thank you for listening.